This lesson is on addition of components. So this is a skill that you'll need to use quite often when you have to take an inclined force. So an inclined force is one that's not vertical or horizontal. Okay, so these are inclined forces because they're not at 90 degrees or horizontal, 180. So what you need to do with these forces is you need to resolve them into their components. So the parts that are vertical and the parts that are horizontal. So this is almost the reverse of the last two things where we were looking at a vector, and we were trying to come up with a resultant. So we were actually looking at situations where you might have two vectors like this, and we were using either the triangle method or the parallelogram method. So if you were to draw rays, this is a parallelogram method, that would be the resultant force. Okay, so that was what we were looking at the last lesson. So this is kind of the opposite of that idea. Okay, so what we're trying to do is find the parts of these inclined forces that are vertical and horizontal. Now you might be saying, well, why do we need to do that? Why do we need to break it down? Well, later on when you do truss analysis, you will need to take your inclined forces and resolve them into their horizontal and vertical components. That's one of the things you need to do, one of the first steps when you're doing that type of analysis. So you'll be doing that in year 12, but you'll need this skill, breaking down an inclined vector into its components. So pay attention. So what we're going to do is, first thing you've got to remember is your sign convention. So just remember that it's just like your Cartesian diagram for mathematics. This direction is positive, this direction is negative. To the right is positive, to the left is negative, up is positive, down is negative. Okay. If you can remember that, you're well on the way to understanding this process. So for this one here, what you would actually do is, if we were to take our 25 newtons, which is at 30 degrees, you can take a horizontal component and a vertical component. And we need to know what the value of those is. And you can use trigonometry to do this. So you've just got to remember that your force vertical is equal to the actual force, 25, times the sine of the angle. And in this instance, it's 30 degrees. So 25 sine 30 is going to give you your vertical component. So when we do the maths for that in our calculator, we say 25 times sine of 30 degrees. We end up with force vertical is equal to 12.5 newtons. And then for our force horizontal, so we go force subscript h for horizontal. It's equal to 25, the force here, 25 newtons, multiplied by, you guessed it, cos 30 degrees. And so our force horizontal for this force here is going to be, I wrote it down here, 21.65. So I've done one decimal place, so we'll go to 21.7 newtons. So that's resolving that force there. It might change colours for the next one. For this one here, we've got an angle and we've got a force. They're the two things we use to resolve this situation. So we're going to do exactly the same thing. Force vertical is equal to, this time it's 20, because it's 20 newtons, times the sine of, and the angle is 75 degrees this time. So force vertical is going to be equal to 19.3, and force horizontal is equal to 20 times cos 30 degrees, and that gives us a result of force horizontal is equal to 5.2 newtons approximately. Okay, so that is how you resolve a force. You just say the force's value multiplied by either the sine or the cos, depending on whether you want horizontal or vertical. So sine is vertical, cos is horizontal. So that's the resolution of forces. Now, we've now got a set of forces vertical and a set of forces horizontal, and we can actually take all of these forces and come up with a resultant. Once again, using a little bit of, in this instance, Pythagoras' theorem. So we've learnt about adding vectors. So if we take our vectors, now just remember too that our force is vertical for this situation here, because we've got that value, a way of working out our pluses and minuses. You need to, so this is, remember we talked about the convention of what's positive and what's negative. To the right is positive, so this has a vertical component that's positive and a horizontal component that's positive. So all these values should be positive. But this one here is going down, okay? So were I to break this down into its components, okay, we would have a component going straight down and a component going to the left. So both of these are going to be, as you can see, down is negative, to the left is negative. So this is going to be negative and this is going to be negative. So our values here are both negative. So we should put those in, because if we don't, if we're calculating our resultant, we're going to get it wrong, okay? So once we've got those values, you can do your addition of vectors to work out what the sum of the forces vertical is. So just remember that in this engineering, you're going to see this symbol quite often, so you better learn it now. We draw an arrow, and this is a way of writing it too. Do this working out the same way, because this is the way examiners are going to expect to see it, okay? We're going to draw an arrow up with plus. That's telling us that we're using this convention. And then we're going to go, so this arrow says up equals positive, okay? This is sigma. It's a Greek letter, and it means, for all of you people that don't do advanced mathematics, the sum of, that's what it means, the sum of adding up, okay? So sigma, so up is positive, sigma of forces vertical is equal to, and we just add those two values, okay? So 12.5, and we're going to go minus 19.3, and that should give us 6.8. So sigma up is positive, force is vertical, equals minus 6.8 newtons. Okay, so that's how we always set our working out there. Up positive to tell us what convention we're using. Sigma, force is vertical, equals that. Okay, and then we do our horizontal component. So we go across is positive, okay. Sigma, force is horizontal, is equal to 21, what did we say it was? 0.7. .7 minus 5.2. So we end up with 16.5. So I should have brought a calculator with me, but that's all right. So sigma forces horizontal equals 16.5, and we know that that total value is going to be positive because it's to the right. So we've got a value here, which is a force vertical that's resultant, and we've got a value here that's horizontal, okay? So now we need to work out our resultant, okay? Now if you've got a horizontal and a vertical, we can use Pythagoras' theorem to come to a solution, okay? So the final working out would be, we could draw a vector diagram that was 16.5 newtons this way, and going down 6 point tip to tail, minus 6.8 newtons. And of course, that gives us, when we make our resultant, and let's do our resultant in a different color just to make it stand out. We're going to go like this and say force resultant equals question mark. Now we know that's 90 degrees, so it's a 90-degree triangle, so we can use Pythagoras' theorem to work this out. So we can go FR is equal to the square root of 6.8 squared plus 16.5 squared. And when you do all the working out, you should get something approximate that approximates 17.8 newtons. Okay. Now, as it is a a force, it's a vector, you need to have an angle as well. So we need to work out this angle here, theta. Okay. What does theta equal? What are we going to use to calculate that? We are going to use trigonometry. Okay, so we're going to say we've got an opposite and an adjacent, so toa. So we need to use, what have we got? The opposite adjacent. So opposite hypotenuse, adjacent hypotenuse, toa. Opposite on adjacent. Okay, so opposite on adjacent. So the SOHCAHTOA that you've been using, it has a use, okay, for this situation in engineering. So we go tan theta equals 6.8 over 16.5, and we get approximately, when we do it as an angle, theta will equals 22.5 degrees. Okay, so our final answer, we'll write it down here at the bottom of the board, is force resultant is equal to 17.8 newtons, and we draw a horizontal line and a line going down, and we go 22.5 degrees. And that is our answer, and that is how you do addition of components. So we've learned in this lesson, or you should have learnt in this lesson, how to break up an inclined force into its horizontal and its vertical components. To make sure you understand how to do that, and that's shown to you down here and down here. Once you've got those components, we've then used our knowledge of adding collinear forces, which we did in another video, to come up with a resultant forces vertical and a resultant forces horizontal. Now you need to understand this symbolism here, okay, of sigma, and this idea of showing your convention that you're using, because that is all stuff that they'll expect you to do when you're setting out. Once again, when we go into truss analysis and we look at moments and things like that, you need to know this type of setting out of your work. You need to set your work out like this, okay? Get in the habit of doing it now. Don't just start doing it your own way, because when the examiners are marking your HSC, some of them are very bright and might spend the time to work out what you're trying to tell them, but a lot of the time they won't. So please do it this way. And then we get to our final working out using Pythagoras' theorem and trigonometry. Hope that all helps. Pause the video, make sure you get this all written down in your notes, and have a crack at doing some inclined examples to see whether you actually understand this concept. See you next video.